Okay, so today we're starting a new chapter. We are starting chapter 3, which is about some new relationships between lines, known as parallel lines and perpendicular lines. And our first lesson today is going to be talking about parallel lines and transversals and that relationships that are caused by those. So previously we looked at those angle and line segment relationships and the theorems that prove them and how we could prove those new theorems. Now we're going to identify the relationships between two lines or two planes and be able to name some new angle pairs formed by those lines and transversals. So we have a lot of new vocabulary. Okay, we have parallel lines, skew lines, and parallel planes. That is what we're going to be looking at first. Then we're going to define what a transversal is, and then look at these new relationships between angles, which make up the rest of this particular lesson. So a set of parallel lines are coplanar, and they don't intersect. Okay, they will never intersect. And we can see that there's this shorthand way of showing that with these two lines straight up and down. And just like previously where we used a slash on different segments to indicate that those segments were congruent, we can use one of these arrows like you see here to indicate that the lines are completely parallel, that all points on each line are at equal distance to the other line. Okay, we're also going to learn about skew lines, which are lines that are not intersecting, but they are not coplanar. Okay, in the example here, L and M are skew. And of course, parallel planes like parallel lines are not intersecting and remain the same distance apart. So here we're asked to name all segments that are parallel to line segment BC. So line segment BC is this right here. Now, what was the definition of something that was parallel? It needed to be something in the same plane that never crossed. Coplanar lines, okay, that do not intersect. So I see one here. Okay, that is the same distance from BC. I see one here that's the same distance from BC. And in both of those cases, they can be in the same plane. Okay, we can see that they are part of these faces. Now, in the answer that this textbook is giving, they also say that EH is a parallel segment. That would be true if we actually draw another plane through this right here. Okay, name a segment that is skew to EH. So it's something that needs to be on a different plane, but remains at a distance. Okay, so EH, this back one right here, the skew is AB, CD, BG, or CF. All of those are never intersecting with EH and exist on different planes. Okay, name a plane that is parallel to ABG. Remember that a plane is defined using 3 points. So plane ABG is this plane right down here. Okay, what plane is parallel to that? Well, there's only one that we can name here that is an equal distance at all times, and that's this one right here. You need to name it using 3 points. They gave an example name as CDE. You could have called it plane EFC. Any 3 points would have defined that plane. Okay, so we need to name a plane that is parallel to plane RST. Okay, RST, we're looking at this point, this, and this. So we're dealing with this top plane, the top surface of this box. To be parallel, it's certainly not going to be any of the sides that are coming down. It's actually going to be the bottom of the box. So I need to see some combination of W, X, Z, or Y. Okay, T is not contained in that. S is not contained. Q, all of those are from the top level of the box. So our answer is C, plane W, X, Y. Okay, name a segment that intersects YZ. Okay, so this is really, something from previous. This is really nothing new. We're just looking for an intersection of segment YZ with another segment. Okay, this is something that we learned back in chapter 1. So our choices are X, Y. Okay, that seems like a possibility. WX, that appears to be parallel. QW, that I'd say that this one here is parallel. This one here is skew. It's never touching, never crossing, stays a distance apart, but it's not on the same plane. RS also is skew. So the only one that actually intersects is A. Name a segment that is parallel to RX. So here's our RX. Once again, let's run through the options. ZW over here. That appears to be skew. TZ, that seems like it's a possibility. QR, that is actually intersecting. And ST is also skew. So our answer here is TZ. Okay, they never cross, and we can draw a plane between them. So now, they actually don't go into defining what a transversal is. Okay, a transversal is a line that intersects 2 or more coplanar lines at 2 different points. Okay, so this line T here, okay, that entire line from going all the way through, okay, is known as a transversal. It's a line that intersects 2 or more coplanar lines at 2 different points. Okay, and because of this, we get these new angle pair relationships. Okay, we have interior angles. Interior angles here are angles 3, 4, 5, and 6. They are to the interior of the coplanar lines that the transversal is crossing. We have exterior angles, which are outside of that region. You can see that the interior is colored green, the exterior is colored blue. Okay, so not between these two lines, Q and R, I have these exterior angles, 1 and 2, and 7 and 8. Now, consecutive interior angles are interior angles that lie on the same side of a transversal. Okay, so 4 and 5 are both on the left side of the transversal, and they are interior. So they are known as consecutive. Okay. Non-adjacent interior angles lie on opposite sides of the transversal. So we could say like angle 3 and angle 5, or angle 4 and angle 6. They alternate sides in the interior. Alternate exterior angles. They're non-adjacent exterior angles that lie on opposite sides of the transversal. So this is similar to the interior, except for the fact that we have to look in the blue region. We could say 1 and 7 or 2 and 8. Now, corresponding angles lie on the same side of the transversal, and they're also going to be on the same side of the lines Q and R. Okay, so it's either going to be above the line or below the line, Q and R. So corresponding angles here are 1 and 5, or I could say 2 and 6, or I could go below and look at 3 and 7, or 4 and 8. So we have all these new relationships that we are going to be using to prove, what is congruent to each other, what sizes these things are, based upon whether or not they are interior or exterior, whether they are consecutive or alternate, or if they are corresponding. Okay? Consecutive, think same side. Alternate, you switch from one side to the other. And corresponding, we end up on the same side, both as far as left, right, or top, bottom. Okay, it's going to include both. So let's classify the relationship here between angle 2 and angle 6. Well, angle 2 is this right here, and here's angle 6. Okay, so right now this looks to be an interior angle. This is an exterior angle. Okay, both of these are below this transversal. They're on the same side of the transversal, and they're on the same side to the right of the lines that are forming them. These are corresponding angles. Okay, this was the last case that we discussed on the previous page. Classify the relationship between 1 and 7. Okay, 1 is here, 7 is here. So they're both to the exterior of line A and B. They're on alternate sides. One's on the top and one is on the bottom, of the transversal. As a result, this is an alternate exterior set of angles. They're to the exterior and they alternate. Okay, classify this relationship between 3 and 8. So they are interior. They are on the same side. These are consecutive interior angles. Classify the relationship between 3 and 5 as alternate interior, alternate exterior, corresponding, or consecutive interior angles. Well, here we have angle 3 and angle 5. So start thinking, are they interior or exterior? Are they consecutive or are they alternating? Which is the case? Okay, both of them are to the inside of lines A and B, but they're on opposite sides of the transversal. Okay, so these are alternate interior angles. You'll notice that the interior or exterior tends to come after identifying whether they are alternate or corresponding or consecutive. Okay, classify the relationship here between 4 and 5. Now this looks more complicated, but we don't even have to consider this last line over here, this line L. All we have to be concerned with is M and N and the transversal P. Okay, so once again, are they on the same side or are they on different sides? Well, these look to be the same side, so I'm not expecting that they're alternating. Now they are in the interior between M and N rather than the exterior, so I'm expecting that these are consecutive interior because corresponding, I would expect corresponding to be 4 and 6 or 3 and 5. They are on the same side, both of the transversal and of the lines. Here the answer is D. Okay, classify the relationship between 7 and 9 here. Well, we just talked about something similar last time. These are on the same side of the transversal. They are on the same side of the lines. They're both to the left. This is corresponding. Okay, classify this relationship between 4 and 7. Okay, right now, are they alternating the transversal or are they on the same side? These appear to be alternating, top and bottom. They're both to the exterior. Your answer is alternate exterior angles. Classify this relationship, angle 2 and angle 11. Now in this case, we can ignore what's happening with M. Okay, it's actually rather irrelevant. We see that they are to the interior of the lines. We see that one is above the transversal, one is below. So this is our alternate interior angles. Okay, so a slightly more complicated word problem. The driveways at a bus station here are shown. So we have many different lines. We need to identify the transversal that connects angle 1, which is here, and angle 2. And then classify the relationship between the pair of angles. So which line is crossing both 1 and 2? Well, this S is shown with arrows on both sides that says, hey, this really connects all the way through. It is continuing on forever and ever. And there's only one line that is crossing both. We see this intersection right here. 1 and 2 are on the same side of transversal V. They also are to the left of both our line X and our line S. If they are on the same side, and also, same side of the lines and same side of the transversal, what are these known as? Corresponding angles. So the answer here is I identify the transversal as line V, and angle 1 and angle 2 are corresponding angles. Okay, identify the transversal that connects 3 and 4. Okay, here's angle 3 and angle 4. Angle 3 is really this angle right here. Angle 4 is this angle right here. Okay, what is our transversal? And what is the relationship? Well, I would say that these appear to be interior angles rather than exterior. Your transversal is line B. Oh, sorry. I did entirely we went back by accident. Huh. I was on a completely different one. Angle 4 and angle 5. Here's our angle 4. Here's our angle 5. Okay. We need to identify the transversal and classify the relationship. Okay. The transversal that is cutting both of these, we have this line and this line being cut by transversal here, transversal Y. They are interior. They're on the same side. So we have line Y as the transversal, and these are consecutive interior angles. Okay, here's a group of nature trails. Identify the sets of lines to which A, this is line A, what is that a transversal for? Okay, line A crosses line C, line A crosses line F. If we extend these out, will it cross more? I think there's possibilities for that. This is a transversal for all 4 lines C, F, D, and E. Remember that lines, rather than line segments, are continuous and will travel on in the direction that is given. Okay. Identify the sets of lines to which B is a transversal. So here's B. I can see that E will cross, F crosses, C crosses, D crosses, but it never crosses A. A and B are parallel. Okay? Which of these lines is C a transversal for? C is right here. This is crossing A and B and D and E and F. It crosses every single one. So I think that this is probably a reasonably easy start, and good luck with your homework.